it's about writing answers to questions. A lot of times, it's easier to create your bar charts and so forth just by hand. You can sketch them. That's okay. I don't have a problem with that. In some cases, I think you'll find it easier to do in Excel. And that's part of the reason why I use it in class. A lot of questions are easier to address in Excel. But, you know, it could be that this is, you know, I'm asking you too much. And you can do it by hand. I do have students who never touch Excel. You know, somehow it will sully their fingers. But the thing is, what I'm trying to do, you see, if you become an Excel wizard, you'll get a raise at work, you'll quickly rise through the ranks to be the president. Well, maybe not. Actually, if you become a wizard in Excel, probably all your fellow employees will expect you to do their Excel work. And you'll be stuck in a technical position the rest of your life. Well, Excel is a standard way of communicating information in our society, or spreadsheets. That's why I encourage you to use it, to learn how to use it. You don't have to use it for everything. Use it when you can. Okay? I would encourage you to practice this. I do think that if you learn Excel at least a little bit, that will be a benefit in your career. Okay? If I knew the magic to succeeding in careers, I'd be retired by now. I'd be at home sitting in my couch watching cartoons on Saturday morning like I did when I was a kid. Okay? All I'm saying is Excel is a useful tool. I mean, in the world today, I mean, you know, when I started out, there was no Excel. There were no word processors. And there were no PowerPoints. None whatsoever. You did everything by hand. Or if you did something nicely, then you had a graphic artist that did it for you, which was really expensive. Times change. Today, word processing, probably, is there anyone who has not used a word processor? If you were to talk to people my age, okay, I don't know when the first word processor, I probably started using one when I was probably in my first engineering job. I was in my early 30s, okay? But prior to that, you used a typewriter, heaven forbid, or if you made a mistake, you had to restart, okay? The world has changed, and an essential tool, I mean, when you work today, a lot of the work is via a computer. If not Excel, something very equivalent to it. If not Microsoft Word, something equivalent to it. The more, you know, you need to have those basic skills, and I think Excel is probably one of the more challenging tools to learn, but it's also, I think, quite useful. All those nice charts you see everywhere, someone created them in either an Excel or something like Excel. You know? And I'm assuming that at least a few of you will probably want to go out and get a job after all this is done, after you've racked up all the debts you get from education. Some of you I probably are already working, all right, and you will do better, I think, you know, having a greater skill set. I think the economy must be improving. And the reason I say that is because I think the enrollment at PCC has actually gone down the last couple of quarters. Because students are saying, why would I want to go to class when I can go out and earn some money? Okay? When when the, you know what hit the fan in 2008 and 2009, just the enrollment just exploded here at PCC and all community colleges. So even students who had graduated from undergraduate programs were coming back to PCC, and a lot of them came back to stat classes. Yeah, I had lots of people who were already had their bachelor's degree. I had in a couple of classes that had engineers. Actually, the engineers were working. I don't know, there was just a flood of students coming back, and now there isn't so many. So I'm assuming it must be easier, as a rule, to get a job today than it was. But the reason I use Excel is I think it's a good thing to know for your career. There's no magic in careers. They're always challenges. They're always, no educational course can ever provide you with all the challenges. You probably already know this. I mean, it's a lot of work is you learn it on the job, okay? You practice and you learn it there. But again, Excel is a really good tool. There's not a whole lot. I mean, I can't change, the employment picture for anyone, let alone for myself, all right? But I can teach you how to use Excel, which I think is a valuable tool to learn how to use. I mean, knowing Word is also valuable, although most people, I think, probably can learn that on their own. And then PowerPoint is, again, another tool. And there are other, Windows or the Mac has equivalent products. They have something called Pages as a word processor, Keynote as for presentation, and Numbers for a spreadsheet. There are open office versions of these tools. And today, even if you type email, you can do some formatting. You can change words from italicized words and so forth and so on. So it's just become the kind of standard by which people work today. Okay. Everything that we do today in Excel, you could do by hand. And did I tell this class that when I was in a stat class, we had these mechanical multiplying devices? Did I talk about this? Yeah, and they weighed about 50 pounds. You'd flip a switch and you could hear the motor running, and you'd enter in numbers, and then you'd say multiply, and it would crank away, and it would do the multiplication for you. Now, you could also do computer programs, but you would take what's called a card deck. You'd type that up yourself, often. You'd submit it to the computer center, and then you'd come back the next day for the answer. Today you enter the numbers, you do click, and it's right there. It's instantaneous. That changes the way in which the world works. It's no longer to have an answer, wait 24 hours for an answer. And that's just, it's changed. All right. Fortunately, I'll be retired here in a few years, and I won't have to worry about any more changes. I just have to worry about getting older. All right. So I do, I'm trying to encourage you to learn how to use Excel, but, again, you can actually get away in this class without ever using it. I think it's, now for the exams and the quizzes, we're going to have our first quiz next week. During the quiz, you can use Excel if you want to. You can use a calculator if you want to. Some of you may be so good at math, probably not, that you can just use a pencil. When you were my age, you often did things with paper and pencil because it was easier to do it that way. All right, but you can use a calculator on the quiz next week. This will be adequate. All right, you can use Excel. Or, I mean, in a lot of the problems basically will be a matter of simply doing some fairly simple calculations, all right? And you can almost get away without a calculator, but I would always bring this. There's one on your desktop as well. You can use that as well. Okay? All right.
How many chapters will the quiz cover?
The quiz is going to cover, I'll do something like the following. I'll give you some numbers. I'm going to ask you to compute the mean. We're going to talk about that now. I'll ask you to compute probably the sample variance and the sample standard deviation. I may ask you to compute what's called the 5-number summary. And then I may ask you to a problem similar to questions from chapter 2 where I ask you to identify who and so forth. Okay? If you look online, look in the quizzes, and you can see what sorts of questions I asked in the winter of 2012. Again, we're going to cover all these topics, mean, variance, and standard deviation today. And what I normally do is I give the quizzes at the end of the class period. So this will be, I don't know, maybe 12:45. I'm going to do the quiz. The exams I do at the beginning of the class. So we start at 8 for the exams. But the quizzes I do at the end of the class. Yes?
Does the quiz include material that you cover that class?
No, not the day of the class itself. But anything I cover today will potentially might be on the quiz. I mean, typically with the first one, I want you to know how to compute mean, variance, standard, that sort of stuff. All right? Okay. Let's talk about the ideas in chapter 4. And to talk about these ideas, let's see. I think what we'll do is we'll look at some of the data in one of the problems in the text. Again, I'm going to use Excel, okay, because Excel will do a lot of work for you. And what I'm going to do is I'll tell you the problem. Okay, if you look on page 74 of your text, if you didn't bring your text, maybe you can look on it with your neighbor. Someone, apparently at one time, measured the neck sizes of 250 men for a health study in Utah. Page 74, problem number 22. All right, so I'm looking on page 74, problem 22. Before we continue, let's see if I can read it. Doesn't look very dark. See if I can. Hopefully that's a little better. And we will keep 6. Okay. So that's the data I'm going to look at. Now, the data is already summarized for you. I don't think this is a problem I assigned, as I recall, this quarter. But what I'm going to do is I'm going to create a chart that looks very similar to what is given in the text. I'm going to show you how to do that in Excel. You can do this without Excel. But there are 250 values in this data. So if you're going to do this, and you don't have most problems, I never ask, I mean, all the computations are done for you, but I would just show you how you do this. Okay, now, there is a file on the website. Let's see if I can, well, I guess it's not there. And it's called, let's see, I think it's called Next Size. Yeah, there we go. Except, oh, I know what I'm going to do here. This is the finished file from, and so what I'm going to do here is the following. We're going to start from scratch. And so this is how we'll do it. I'm going to copy this to a new spreadsheet, which will then look like your copy of this file. So I'm starting from scratch. If you download the file, it should look something like this from the website.
Where's that?
If it goes into the website, go into the folder called examples, and then it says next sizes. Now, what you want to do is you want to click on the tab at the bottom on the left. Okay? So, yeah, because I have, I guess the tab that comes up by default is just a summary of, or a smaller collection of numbers. Okay. Now, what I want to do is the following. Is I want to divide all these numbers into what we call bins. There will be a smallest size, and the largest next size, think of this line as something like the number line. Somewhere over on the left I have 0. What I'm going to do is the following, is I'm going to divide the interval of numbers from roughly the smallest next size up to the largest into a number of sub-intervals. They're called bins or called classes in statistics. And we're going to count the number of individuals who have a next size in that interval. Okay? Now the smallest next size I think is 12¼ inches, roughly. And the largest one is I think 17¼ something like that. Pardon?
128.
Okay. So I'm going to show you how to do all this in Excel. What's the problem if you don't use Excel? Now I've never asked you to analyze in a homework problem this much data. This is a lot of data. If you did it by hand, you'd have to take all these 250 values and sort them by hand. Okay? They're actually, you can learn how to do that relatively quickly. Okay? But Excel will do it even quicker than you can. All right, now, there is a nice little function in Excel that will, what you can do is you can give it a range of cells, and Excel will report back what the minimum value is. Okay? So let's do that to start with. First of all, I often enter in text or words to annotate or describe what I'm doing. So what I'm going to do first, I think I'll make this a little bit bigger. Hopefully it will be a little easier to see. What I'm going to do is I'm going to compute or determine the minimum of all of these values. And I'm going to determine the maximum. Now, if I'm going to compute something or determine something in Excel, the first character I enter in is an equality symbol. And that's in the upper right-hand corner of your keyboard. Now, there is what we call a function that will determine the minimum value in the list. Surprisingly, it's named MIN. So I'm going to type in MIN. You'll notice that you have a number of functions, all of which begin MIN. Knowing which function you want, basically, you just learn it from someone else, basically, to start off. All of these other functions, they're, well, minute and inverse. Oh, yeah, I don't think we don't even want to go there. The first one is what we want. So what I can do, there are two things I can do here. Is I can double click on the list below, or I can simply complete the name and follow that with what we call an open parentheses. Well, there's nothing more to type as far as letters are concerned, so what I'm going to do this time around is I'm just going to insert a parentheses. And that's, you have to hit Shift and then a 9 above the 9. Now, what I now need to do is I need to tell Excel, well, what is the minimum? I need to tell it where to look. So where I want it to look will be in the numbers beginning in this first cell here, all the way down to the bottom. The first cell is A2. The last one, I think, is A251. So somehow I want to get in there A2 colon A251. Now, the only reason I know that the last entry is in row 251 is this is the second time I've done it this week. All right? So I'm going to pretend I don't know where the last value is. Now, to select a range of cells to provide as an argument to a function, you can click on that first cell there with your left mouse button. At the same time, keep it down, don't let it come up, and start dragging it downward. Now what will happen is the window itself will scroll, and you can kind of get it to different spots that may scroll a little faster. But eventually, I will get to the last entry here, namely in 251. Now if I use this little wheel, or I can move my cursor to the right and use the slider on the right, move it to the top, what has happened is Excel took that selection of cells and translated it into references A2 to represent the first cell, A251 to represent the last, and the colon means everything between those two. Yeah. Now, what you can do is you can just do a delete and type in 251. You can actually just type this in. Now, following this, I want to enter in a parentheses, and that's above 0 with a shift, and I'm going to hit enter. 12.25. That is the smallest number amongst all those 250 values. If you had done this by hand, 10 or 15 minutes later, you would probably get the smallest value. All right, now, what about the maximum? Well, wouldn't you know, there's a function called max, M-A-X. If I'm going to compute something, what's the first character I enter? Equals. And max is M-A-X. Now, there are only two functions whose first three letters are M-A-X. We're going to ignore that second function. That's not the one I want. I'm going to insert an open parentheses. Now what I could do is I could click and drag over those very same cells. But you know what? I already know this cell. I'm just going to type them in. Now, I don't have to use capital letters. So I'm going to type, see the first cell is A2. Now Excel turns that to a blue saying, I'm going to interpret this as a reference to a cell. Now, I enter in the colon, which is shift and then above the semicolon on the right-hand side or next to the L there. And then I'm going to enter in A251.
Why do we use 250 instead of 251?
Because the last row, you see the first row has annotation. So if I have 250 values, the last value has to be in 251. All right. Now I'm going to hit shift and enter a closing parentheses. Then I'm going to hit enter. The maximum next size is 17.28.
So it doesn't matter if you use a lowercase a.
No, it does not. You can, in referencing cells, you can use either a capital letter or a small letter. Either one will work. Now, I suspect that these 250 males were probably college students because a maximum neck size of 17.25 inch would probably not apply to males my age. Their neck sizes, along with everything else, every other dimension, has gotten larger. Okay? So, now, the minimum is the smallest, and the maximum is the largest. So I have this number here, and I have this number here. Now the next thing I'm going to compute will be the range, R-A-N-G. R-A-N-G-E. Now, I want to take the difference of those two numbers. So if I'm going to compute something, the first character I enter is equality sign. Now, rather than retype in these numbers here, I want to reference the cells that contain that information. So I'm going to click on the cell here, which has the maximum And then I'm going to use the subtraction symbol, which is across the top row. And then I'm going to click on the cell that has the minimum. So I claim I will get the answer if I want if I take this number minus that number. Now I hit enter. The difference between the maximum and the minimum is 5.04. Now, if we were to look at the data in Excel that they provide you online, they actually display more than 2 decimal places here. So what I have done is I've changed slightly how the information is displayed. If, for example, if I come back to, say, this right here, see, the actual number that's been stored is given out to 6 decimal places. I'm displaying only 2 because you can't measure someone's neck down to 6 decimal places. It's not humanly possible. All right. Now, between the smallest and the largest is about 5 inches. Now what I'm going to do is I want to divide that range of numbers into little bins and count the number of values in every one of those bins. Let me set up a table here. And I think what we'll do is we'll put the annotation right. Let's do it right here. I'm going to type in lower bin. And I'm going to type in upper bin. And my first 2 entries will be the following. 12.0 and 12.5. Now, to move from one cell to the next, I typed in 12 and then I hit tab. Or you could simply hit enter and then use your cursor to select the next cell.
For the arrows.
Well, what I'm doing here is the following. You see, the smallest is 12.5, or excuse me, 12.2. So what I want is I want the lower value for the first bin to be this number or smaller. Why not use 12.0? That's a nice choice. Do you have something against the number 12? Oh.
Because the lowest number is 12.24.
I'm sorry?
Because the lowest number is 12.24.
Yeah, and I want a number that's lower than that. Actually, I could have used 12.2, or I could have used 12.1. Tell me. This may not be true of females, but for males, when you buy a shirt, what values do they, what increments do they have in neck sizes? Half inch. So when you go to buy a shirt, I don't know if this is true of women. I mean, see, a male neck size, it will go, it usually gives you a range of values, maybe 15 to 15.5 or maybe 15 to 16. But usually the smallest increment is a half an inch. And the boundaries are always either at a half or at a whole. So you might have 12, 12.5, 13, 13.5. So let's use that.
Get it to 30.
And lower bin is 12, upper bin is 12.5.
Because
it, 0.5.
Well, okay. The reason you agree that this number here lies between those 2 values.
Why do we use the maximum?
Oh, well, we'll get there. Hold on. You're jumping ahead. See, if I used, say, 17.5 here, how many numbers are between 12 and 17.5? 250. That's not going to be very helpful to me. What am I trying to do? I'm trying to divide the range of numbers from the smallest to the largest in little bins and count the number of values. That's what we call a frequency table or a frequency distribution. Actually, the term is frequency distribution. Now, so what I've done here basically is as follows. This right here is 12. And the next boundary is at 12.5. Now the next bin will start at 12.5 and go up to 13.0. So for my next bin, I'm going to type in 12.5 to 13.0. So the first bin will be from 12 to 12 and a half, and the next bin will be from 12 and a half to 13. Now what I want to do is I want to continue in this pattern and make sure I have bins or ranges of numbers that include all possibilities in my data. So somehow I have to continue this pattern until the upper bin value is bigger than 17.25. So the next one here, I would enter this to be 13 and this to be 13.5. Now, I'm going to have Excel do the work. I'm going to click with my left mouse button above the 12, keeping that left mouse button down, and then drag down to the bottom. And I have selected these two cells. There's a pattern here. The first number is 12, the next one is 12.5. Excel sees this pattern and says, if I extend this formula down, every subsequent value in this column will be increased by 1/2. So I move my cursor to the lower right-hand corner. I click and hold and I drag that downward until I get to 17. Oops. I could have entered those numbers by hand. That worked just as well. Now over here in the second column for the upper bin, I'm going to select those first two cells, move the cursor to the lower right-hand corner, and drag that down. Now what do I have? The first bin is from 12 to 12.5. The next bin is 12.5 to 13. The next bin is 13 to 13.5, and so forth. And the last bin is from 17 to 17.5. Will every number in my list fit in one of these bins? Yeah, every single number will be in one of these bins. Now, the first thing I'm going to do is I'm going to change the formatting, that is how these numbers look, by displaying all the numbers to one decimal place. This is purely a matter of making it look a little bit nicer. Yes?
Can you see how we got the word in that ribbon?
Oh, these two values here,
Yeah.
I said, well, what's a reasonable choice?
Okay.
You could have made other choices.
Okay.
Let's just for now just use 12 and 12.5. To change the formatting of these cells, I select all of them. I do a right click and I hit Format Cells. And then I come down here to where it says Number. And then I'm going to use this little rocker switch to take this down to 1. It's the same numbers. I've just displayed them to the same number of decimal places. It's a little easier on the eyes. Okay, now, each row, beginning here, ending up here is what we call a bin, or sometimes it's called a class. In mathematics, we would call it an interval or a subinterval. What I want to do now is the following, is I want to count the number of values in each one of these bins. Now you can do this by hand. How would you do this by hand? And go ahead. Oh. Yeah, you could do, that's actually what you did in my era is the following. You'd go down the list, and every time you counted the number of one of these bins, you'd put a little tick mark, a little dash. That's how you did count. I mean, people still do it that way. Okay? But we're going to have Excel do all the work for us. Now, how many bins do I have? Well, that's the number of rows from here to here. And I think there are 11. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 bins. When we create what are called frequency distributions, typically we want between 5 and 20 bins. The choice is dependent upon the data that you have. I have a fair amount of data in this case, and using 11 bins seems to me reasonable. And it's also going to be consistent, I think, approximately with what the author did in creating that histogram, what we call a histogram, in the text itself.
This little picture is a histogram?
That's correct. Yeah, we're going to recreate that in effect. Now, there is a nice set of tools in Excel called the Data Analysis Toolkit that will count for us the number of values in each one of these bins. And it will do so like that. Let me show you how to do that. If you click on this little tab at the top where it says Data, you should see on the right-hand side a little icon that says Data Analysis. You may not, and if you don't, I'm just going to check here. Click on, okay, all right. Click on data so we can see. Yeah, okay. So you should see that little icon that says data analysis. Is there anyone who doesn't see that, is tracking what I'm doing? Aha! You were a lucky one. Let me show you how to fix this. Lucky or unlucky, as the case may be. What happens if you don't see this?
His shirt was between 12 and 12:05 in that bin.
Aha! I've got two lucky people. This is what you do. See this little green tab up there? If you've got the data analysis toolkit icon there, don't do anything. Just sit tight for a moment. If you don't see that, click on that. You see a little entry down here called Options. Click on that. Now over on the left-hand side, you'll see something called Addins. Click on that. And then way down at the bottom of that dialog box, you see Manage Excel Add-ins, and you see the icon Go. Come down to Go. Now, in this list, you probably have the first entry without a check mark in it. Is that correct? Click. There was already a check mark?
Yes.
Okay. Now what I want to do is I want you to uncheck it. No. Hold on. You don't have to do anything. You just sit tight. Okay, did you, let me just see what you've got here. Okay, now, do OK. And so do OK. Now what we want to do, oops, uncheck it. Uncheck it.
I unchecked it.
Okay, but I'll go back here and uncheck it. Now go back to it. That same. Check it. And then hit OK. It's there. This is one of the features of Excel. It's a bug. Sometimes it does not display this icon in the upper right-hand corner, even though it has been added in. And to think that this company makes money on this product. Okay. Now, so everyone should have this icon up here, data analysis. Now we want to click on that. And you'll get this little menu here. And what we want to do is we want to select the entry where it says histogram. All right. And then we want to hit OK. Now this is what we call a dialog box. I think I've used that term already. Basically what I want to do is I want to tell it what data I want analyzed, and I want to tell it where to find the bins that I've created. Now Excel is a little funny in that all I have to do for the bins is to give Excel the upper value. So all I'm going to do is I'm going to be telling Excel about this column of numbers here, because they can actually figure out the values on the left simply by knowing. You see, you go from 12.5 to 13, 13 to 13.5. It knows the bin widths are a half. So it knows the lower bin is at, the lower bin for the lowest class is 12. And actually it doesn't quite work that way, but it's close enough. Okay, now, this icon right here on the left where it says input range, you're going to click on that icon, and what's going to happen is you'll then select the column of data on the left. That column of next sizes. So what I'm going to do here, I'm going to move my cursor So right here, I'm going to click on that icon. The dialog box collapses. I'm going to use that roller to get to the very top cell of my data right there. I'm going to click on it. I'm going to hold that down with my left mouse button and drag it down to the very last cell. Now, if you look at what has been typed in here, you see $A, $2, colon, $A, $251. That's exactly what we want. The dollar signs are what are called anchoring, and we talked about this when I was creating the analyzing the Titanic data. A dollar sign in front of either the column or the row means when you extend a formula, you don't change the reference to that cell. If it's in front of the column sign, that means that if you move something from left to right across the columns, it doesn't change. If you have a dollar sign in front of the row, that means as you extend the formula up or down, you don't change the reference to the row. If you have a dollar sign in front of both, nothing, it never changes when you extend that formula. You actually don't need that in this case. I'm not quite sure why Excel does it this way, but it's okay. There's nothing wrong with this. So now what I'm going to do is I'm going to click over here to re-expand my dialog box. Basically, I'm telling Excel I'm done selecting my data. Now the next thing, it says bin range. So what I want to do is I want to click on that icon. And if the bin range is not visible, then I'm going to use that little wheel to the top, or I can use my slider on the right. And what I'm going to do is I'm going to click on this cell right here, drag it down to the 17.5. I don't need to select these. It's going to figure those out by default, basically.
Can you select the lower bin? You have to select the upper bin.
No, you definitely want to select the upper bin. You don't have a choice. Yeah, do not select the lower bin. Okay, so I'm going to basically click on that very first cell and drag down to the bottom. And I'm going to click OK. And here, you'll see dollar, in my case, D, $8, colon, $D, colon, $18. Okay, now what we've done here is I've told it where the data is and where the bins are. You don't actually need to create this lower bin value. Excel actually figures that out. But I do it this way because I think it's a little more visually pleasing to see it in this fashion. Now, the next thing I'm going to do is there's what we call a radio button. It says output options. I want to click on that top one. And then what I'm going to do is I'm going to click on this icon over here on the right. And then what I want to do is I want to click on a cell somewhere in this spreadsheet, which is going to tell this tool where to display all the information it's going to provide to you. What you want to be a little careful about is that you don't overwrite something you already have created. What you do is you want to select a cell where there's nothing below it and nothing to the right. You have a lot of choices. And in fact, if it's going to overwrite something, it will probably give you a warning saying, don't do that. You're going to overwrite it. So what I'm going to do is I'm going to click on this cell right here. And my data will be displayed downward and to the right that this tool will create. I come back up here to the icon there. And then I come over here to where it says, there's some check boxes here, and I want to check the last one where it says chart the output. Okay. I'm going to come up here to do OK. And what I have over here is my frequency distribution, and on to the right, what's called the histogram. Let me scroll that.
I don't see it.
Oh, yeah. The numbers should be the same here. They may be, mine are displayed vertically, and that has to do with the size of my graphics window. If I make it wider, it will display them horizontally as opposed to vertically. What does this tell us? Well, let's look over here. There are 2 individuals whose neck size was 12.5 or lower. There was one individual whose neck size was between 13 inches and 12.5. There are 10 individuals, all right, whose neck size was between 13.5 and 13. Okay, and so forth. Now there is one last bin down here which says more. Basically it says there's no one having a neck size greater than 17.5. Now how long would it take you to do this by hand? Yeah, it'd probably take you a half hour if you're really good at it, maybe 15 minutes. Alright. I probably spent 20 minutes explaining what to do, but once you know how to do it, it takes maybe less than 60 seconds.
What I'm saying is now you can quiz, you want to create a frequency table for this, and
Oh,
how do we do it?
oh, okay, hold on. Yes.
What happens if like your data is only to 1 decimal point, and there's it overlaps, like you have a data point that's 12.5, 13.0.
Okay. If a value is on one of the boundary values, I think it's counted in the lower class, in the smaller class. Now,
So that doesn't get counted into the more category.
actually, the more category would be over 17.5.
How about if it's under?
Well, actually, anything under 12.5 would be counted here. That's why you want to be a little careful about how you set up your bins. Excel has its own way of doing things, unfortunately, and what I need to do is work within the context of Excel. So what I did, you see, is I found the minimum and maximum, and I made sure all my bins included both the minimum and the maximum.
Well, plus if you're looking at it in terms of size of shirt, anybody who wears a 12.24 would get a 12.5 size shirt,
Yeah.
Well, okay.
right?
Yeah, that's true, yeah. You could go from 12.1 to 12 to 12.1, 12.1 to 12.2. You could do that. You'd have a lot of bins in that case. Sure. All my choice of my bins was just in part arbitrary. This would be a good homework problem same thing, but go from 12 to 13. Have one of your bins from 12 to 13 and see if you should be able to do exactly the same thing. You'll get a slightly different looking histogram. In that case, you're going to end up with probably 6 bins, and 6 would be at the lower range of bins you want. It should look roughly like the graph we already have. This right here is called a frequency distribution or a count distribution. This is what's called a histogram. Now what they have done is they have labeled every one, the horizontal, by these upper bin values. And then above those values they've created a bar which is proportional to the count, the number of individuals in that bin. Okay, now, if you look in your text, what you see in the text is similar but not identical to what is here. Now, in this case, let me tell you what I do on exams. And your assignment for next week is to go look at all the exams I posted. I'm not sure I have an example like this. But one thing I could do would be the following. Suppose I gave you this table here, and I gave you these numbers here. Could you create a bar chart from that? Yeah, you should be able to. I think I have an example in the one of those. It may be in the final. I'm not. You have to look through all the quizzes and exams. And if I don't have one there, you could send me email saying we need an example of this, and I'll be happy to post one. See, this information here is nothing more than a graphical representation of this information there. If I give you this, that's a piece of cake. You can sketch that by hand. Okay? So this is how I might ask a question like this, is I give you the frequency histogram, or frequency distribution, and say, okay, give me a histogram. And all you have to do is sketch bars to the appropriate height. Now, let's make this graph look more like what's in the text. What we have what's called a formatting issue. So I'm going to take my cursor. I'm going to place it above one of these bars. It doesn't matter which one, and I'm going to click on it with my left mouse button. And you'll notice here you'll have circles at the corners of the bars. Now I'm going to do a right click. And I'm going to come down to here where it says Format Data Series. And let's see. You'll see an entry here where it says gap width. The gap is the gap between the bars. Typically in statistics we don't want a gap between our bars. Okay? So I'm going to take that slider, what we call the slider, I'm going to click on it with my left mouse button and drag it to the left. So there's no gap. And you can see it fixed it. Now this is a really gaudy blue. If you like this blue, it's okay. I do not. Actually, and it's not what we typically use in statistics. The inside of these rectangles is what is referred to as the fill. So I'm going to click on fill. And what it does, it's done something automatically. What I'm going to do is I'm going to select a solid fill, so I'm going to click on that radio button. And then I'm going to come down here to where it says color. I'm going to make this white. And you'll notice immediately that my rectangles are now white on the interior. Now the border is still blue. So I'm going to click on border. Again, I want it to be a solid line. It's automatic now. So I want a solid line, and I want it to be a black line. I could leave it at that, but I'm going to select border style. So I'm going to make the little lines, the rectangles on the outside a little thicker. The width of the border is 0.75, which is a point is a unit of measurement in graphics. So I'm going to increase that to 1.25. And I'm going to come down here and I'm going to hit close. Now this right here looks a little bit closer to what you have in the text. If I expand this vertically, that is, I bring my cursor, there are some little dots behind it. If I click and drag that downward, I will increase the size vertically. And now that looks approximately what you have in the text. Okay. If you're having formatting problems, let's do that during the break, because you don't have to change what these graphs look like. It's okay to use the one that comes out by default. At break, I'll be happy to show you all the bells and whistles to make it look nicer. Okay. Now everything I've done here you can do by hand. I don't think any problems that I give you, I ask you to analyze 250 values by hand. But this is, again, it's a tool, and I wanted to illustrate the tool and show you how the author got this graph. Now, in addition to Excel, the spreadsheet or the program I'm using, there's a lot of other software out there that does statistical analysis. There's something called R, just the letter R. And if there are geeks, I have one geek in here. No one's admitting it, so all right. If you're a geek, you can actually download it. It's a free piece of software. It will work on a Mac, it will work on a Windows, it will work on Linux. And free is a very good price. But don't ask me questions about R during class. We can ask questions, I'll address questions on R outside of class, but not in class. There's JMP. There's SPSS. Is there anyone here in the social sciences? No one here is in the social sciences?
Yes.
Psychology, sociology.
I like psychology.
You're not in it. No one here is in the social sciences?
Everyone's getting practical.
They don't pay us practical degrees.
Well, social science is social worker. No one's going into.
I currently am, that's what I'm going into.
You're going into what?
That's what I currently am. I'm going into nursing.
Into what? I'm sorry.
Nursing.
Oh, nursing. I see. You want to make some money. Yeah, I can understand. Well, SPSS is statistical package for the social sciences. If you type in Google SPSS, it will take you to the website that sells that software. You can actually, I think, download a student version and use it for 30 days. I'm not recommending that you do it, I just want you to be aware that it will do such things as histograms probably quite nicely. I know R will do it quite nicely. GMP will probably do it quite nicely. SAS will do it quite nicely, and then a lot of software will do it for you. All right? So there are other packages that will do this software, but the nice thing about Excel is most people have access to Excel. And we can pretty much replicate most of what's in the text without too much difficulty. Okay.
I think think that I found that there's a way that you can get the data analysis tools from that.
Okay. The data analysis toolkit comes by default when you have a PC or Windows platform. If you have a Mac, there are what are called third-party tools out there that will do something very similar. However, you have to download it and you have to install it, and it's not going to work exactly the same way this does, I don't think. It's okay to use that, I don't have a problem with it, but I'm not going to, you know, if you want to bring in your Mac, we can fool around with it outside the class time, but I don't want to focus on that.
It says that through Microsoft there's a service pack that,
Oh, is that?
that's what I'm reading here.
Oh, is that? Well, now
I'll try it
that
out this week and I'll see if it works.
would be. You see, there is a newer version of Excel. I think it's, isn't there a 2014 now? And it could be that maybe they've added that to the Mac version. I'm not aware of that. It's possible. I'm sure that Excel has gotten a lot of screaming from people in Macs.
I'll try this week and see if it works.
Oh, okay, yeah. All right. I just did a frequency distribution. We talked about bins. Bins, we can either deal in counts or percentages. In percentages, we would take those counts and divide it by 250. A histogram is a display of the frequency distribution. That's what I created. We'll talk about stem and leaf plots later. We'll talk about dot plots later. There's also something called a box plot. We'll talk about that a little bit later today. When we have data, we want to create a picture because the picture will tell us things that may not be apparent directly from the data. Let's go back to the Excel file. The thing that stands out here is the following. I have two males, or not, well, yeah, I think it's two, yeah, two males, all right, which apparently have very small neck sizes. Now what this could mean, there are two things that could, first of all, it could be real data. It says these are 250 males in a Utah study. Usually people, when people are going to be experimenting on their college students, so it wouldn't surprise me if these were neck sizes of 250 males, all right, in a college. It could be these males have fairly small neck size. That's a possibility. It could also be maybe there are a couple in this group that were very young. Okay, maybe individuals who were, you know, early start to college, 15, 16, something like that. That's a possibility. There's another possibility. The measurement is wrong. When people measure things, they make mistakes every now and then. All right? Looking at the data itself, we're not sure which is the case here. Did we have males with extraordinarily small neck sizes? Or did someone maybe measure their neck sizes incorrectly? If you were actually doing a study here, you'd probably want to revisit, and maybe if you have the names of these individuals, have them come back and remeasure their necks to see whether or not that is the data was correct. It might be. Data which is different from all the rest of the data are referred to as outliers. Outliers are sometimes more interesting than the data itself. But as I said, outliers might be real data, or it could be incorrectly recorded data. That can happen. Okay. When we look at graphs, we want to see if there's a kind of shape or description to the data. Let's go back to this here. If I were to take this graph and flip it around the center, it would not look all that different from what I have here. It has a kind of symmetry about what we call the center of the data. That's not surprising. Biological measurements are often normally distributed. Or they have this kind of symmetry or bell shape. We haven't got the normal distribution yet, but data often has this kind of symmetry, especially when you're measuring lengths, heights, whatever, blood pressure, all the things they measure when you go in to have a physical and so forth. You often see data which, if a frequency distribution and histogram is created from it, you'll see this sort of symmetry. We want to look at the data that is displayed and see what it is telling us. In this case, it's telling us two things. It looks like the data is relatively symmetric, and it looks as though we may have some outliers. Now, we'll do one more slide, then we'll take a break. What I have up here are 6 different examples of histograms. Remember, a histogram is a display of a frequency table. This one up here looks very similar to the one that we just created. We would say it's unimodal. Mode means the peak value. There's one peak value here. As a contrast to over here, this is what we call bimodal. Bi meaning 2. This is symmetric. We don't normally use the word symmetric here. Bimodal says, I probably want to reanalyze the data, change the data a little bit. You would see bimodal data if, for example, suppose in that 250 we had both males and females. We might see some bimodal distribution in that case because the neck sizes of women might be smaller as a rule than the neck size of males, just because males tend to be bigger. So if you see data, which is what we have here, that suggests you have maybe actually portions that are clearly identified as being different, male or female. Okay? When you look at species data, you will sometimes see something like this. Sometimes that has to do with some are males, some are females, or you could have within a given species, subspecies, they look very similar, but there are slight differences between the two subspecies. If we had a graph, a histogram, where the left side looked as though it's pulled to the left, we say it's skewed. We'd say it's skewed to the left. Or we would say it has a left tail, or left-tailed. In contrast, this is skewed to the right. You have bars that seem to be further on the right than the bars on the left. Both of these are bimodal, unimodal. There's one peak, but over here it's skewed to the left, and over here it's skewed to the right. If we had a histogram like this, it's relatively uniform. If we had a histogram that looks like this, over here, it looks as though we have some data which is different from all the other data. That was the example of neck sizes. Here I've exaggerated a little bit. This suggests my data is outlier. I have outliers in my data. Again, when we have outliers, it may be because it's real data and these individuals are just different, or whatever we're measuring is just different. Or it could be the measurements are wrong. You can have both of those cases. And looking at the numbers themselves, you can't tell. You need to go back and ask the question, was there maybe a mistake in measurement? Or were these individuals maybe a little bit different from all the others? Okay, well, let's take a break for about 10 minutes. So I guess what that means by this clock, well, let's be back here by this clock at, well, is 11 o'clock. Okay, and so that's about 12 minutes from now. And if you want me to pretty up your histograms, I'll be happy to do that. Let me grab my glasses.